Hello friends. So in this video I'm going to discuss about a very important topic, and the topic is second law of thermodynamics. Okay. So this is my the lecture 6 in the chapter of thermodynamic. So to understand the second law of thermodynamic, you have to follow all my previous lectures to understand this the second law of thermodynamic very properly. So in this lecture I'm going to discuss about the three statements of the second law of thermodynamic, and also I can discuss the reversible and the irreversible process. Okay. So what are the three statements of second law of thermodynamics? The first statement we can say the Kelvin statement. There are three statements. One is Kelvin, another is Clausius, and another is Planck statement. So first statement is Kelvin. Kelvin statement. So what he said? He said that it is impossible to obtain a continuous supply of work from a body by cooling it to a temperature below the coldest of its surrounding. So he said that it is impossible to get the continuous supply of work. This is the important point. It is the continuous supply of work from a body by cooling it to a temperature below the coldest surrounding. So if this condition is happened, so in that case it is not possible to get the continuous supply of work. So this is the Kelvin statement. The second important statement is the Clausius statement. So what he said that, I'm going to write the Clausius statement. So he said that it is impossible to transfer heat from a lower temperature body to a higher temperature body without use of an external agency. So he said that it is not possible to get it's not possible to transfer the heat from lower temperature to higher temperature without applying any extra energy. The example is, suppose this is a bucket and I can put some water, and the temperature is maybe 10 degrees centigrade in the of that water. So if I need to increase the temperature of the water, so is it possible to increase the temperature of the water without applying any extra energy or extra heat? No, it is not possible. To increase the temperature we must need heat. It means extra energy or external agency. So we must need heat, and by using this heat we can increase the temperature of the body to 10 to maybe any temperature. Okay, maybe 70 degree centigrade. So to increase the temperature of any body we need extra energy. So he said that it is impossible to transfer heat from lower temperature to higher temperature, from lower to higher temperature without using any extra energy. So this is the second statement, Clausius, and the third statement is a Planck statement. So he said that this is the third statement. It is impossible to construct a heat engine that will convert heat completely into work. So he said that it is impossible to construct any heat engine that totally convert the heat into work. So just a rough example, suppose this is a machine, so I am applying some energy, maybe 10 amount of energy. So this is my input. Okay, just this is the rough. But what happened, we can see or we can find that I can get the output is 7 amount of energy. This is my output. So what happened to remaining 3? So this 3 may be the loss factor. So it may be used to break the bond, it may be used to increase the temperature, or maybe lots of things happen in that system. Okay, so these 3 may be the loss factor. So he said that it is not possible to convert in a heat engine to completely heat to work. So this is my energy, and it is not possible to convert this 10 amount of energy into 10 amount of output. I can apply the 10 amount of input, but not possible to get the 10 amount of output. The remaining 3 may be the loss factor, and the loss factor may be varied. In different case, different loss factors are there. Okay, so maybe it may be the radiation, maybe etc. Lots of things happen. So this is a rough idea how it is not possible to get the total heat into work in practical case. But theoretically, you can say it may be possible, but practically it is not possible to get the total heat into work. Okay, some loss factor exist. Okay, so these are the three statements. Okay, and I can see that all these statements are equivalent as one can be obtained from another. So it means all the three statements just a different language, but all the three statements are almost same. So these are the three important second law of thermodynamic statements. Okay, now we can discuss about the reversible and irreversible process. So basically, what is the reversible? Okay, reversible means we can get again from initial position, and initial and final position are almost same. It means our ending and starting and ending point are energy are almost same. Okay, so reversible process I can write reversible process. Okay, so it is a thermodynamic process. We can write it like this: a thermodynamic process is reversible if the process can be turned back such that both the system and the surrounding return to their original states. Okay, with no other anywhere else in the universe. So it means we can say a reversible process, a process which return to its own uh, again return back such that both the system and surrounding return their original states. Okay, so suppose this is A and this is B. So if I start from A to B, so this is not reversible, but if I again return back to B to A and follow the same thing, then we can say this is the reversible. Okay, understood. From A to B and B to A, so my start initial and the final, both the position are A, so you can say this is the reversible. So there are some conditions are there in the reversible. When we get the reversible, a process is reversible only if the first condition is it is a quasi-static. It is quasi-static. So I already discussed what is the quasi-static. That you can see this one term is static. Static means it is a almost it is a rest, and quasi-static means it is not rest but almost a rest. Okay, almost rest, or you can say very slow process. So if the process is very slow, then we can say this is a we can get the reversible process. Okay, and one more thing in case of reversible, no dissipative effect. So what is a dissipative effect? Means no loss of energy. Dissipative means there is no loss factor is there. So to get the reversible process, we must follow these two conditions. One is it is a quasi-static. Quasi-static means static means rest. Quasi means almost rest. Or you can say it is a very slow process. Okay. And another condition we must follow, it is a dissipative, not dissipative effect. If there is a loss factor, then we can get the reversible because some changes may be there. Okay. So to get the reversible process or reversible system, we need two conditions. One is it is a quasi-static, and another is there is no loss factor. Otherwise, we are not getting any reversible process. The second is irreversible. So it is obvious if we are not getting the same system, then it is a irreversible process. So what is the definition of the irreversible process? Irreversible process, you can write any process which is not reversible exactly is an irreversible process. Okay, so in this video we can discuss the reversible and irreversible process and the second law of thermodynamics. So irreversible process, it means apart from the reversible, every process is the irreversible process. Okay, and we also discuss the different statements, the Kelvin statement, Clausius statement, and the Planck statements, and we understood the second law of thermodynamics. And then why you need the reversible and irreversible process, because in the next video we can discuss the cyclic process, Carnot cyclic process. Okay, Carnot reversible cyclic process. So in that case we need this reversible condition. Okay, so I think you understood this topic. So if you have any doubt, you can comment me, you can send me the message, and thanks for watching this video. Thank you.